Today we're going to continue our discussion of arithmetic sequence. I know as you've been doing your practice, what you've noticed is the words explicit and recursive keep coming up. I just wanted to touch on that for just a moment. An explicit formula just means that the formula defines each term in the sequence directly. It allows you to calculate any term in that sequence without knowing the value of the previous term. And the explicit formula is a sub n, which is any term in the sequence, is equal to the first term, a sub 1, plus n minus 1, n represents the number of terms in the sequence, and times d, which is the common difference. So this would be the explicit formula. And any time that you write a formula for a sequence where you are defining each term, that's the explicit formula. The recursive formula, on the other hand, it needs the preceding term's value in order to work. So its formula that defines each term of the sequence using preceding terms. So to use a recursive formula, you'll have to know the initial term or a preceding term's value in order to be able to solve or find the terms. So let's take a look at what that means. Okay. If I take a look at, for example, a recursive formula, which would be this first one right here, we'll call this A, versus a explicit formula, which we call B. As you can see with the recursive formula, the first term had to be given to you in order for you to be able to find all the other terms. So for example, if I had to find the first term, it's given to me. It's 3. But if I want to find any other values for any other terms, I have to use the 3 and substitute it into my formula. So for example, get that out of the way. So for example, if I substitute in a 2 here, 2 minus 1 will be 1. So therefore, my second term can be found by taking the 3 and adding it to the 5, and so I get an answer of 8. So this 3 in term number 1, the value number 1 would come in. Now that I know that my second term's value is 3, the previous term's value, I can substitute that in and add 5 to it because that's my formula, and I end up with 13. So as you can see, the recursive formula requires that you know the previous values. However, when you look at the explicit formula, it's much different. It's different in the fact that we can now find the value of each term by simply knowing whatever term we're looking for. So if I'm looking for the first term, for example, I would just simply substitute a 1 in for n, and my first term's value is 5. If I'm looking for my second term's value, I just simply substitute in a 2, and my second term's value is 8. And if I'm looking for my third term's value, I simply substitute in the 3, and my third term's value is 11. So you see, I didn't need to know the previous terms. All I needed to know was what term I was looking for, and I could substitute that in for n. So now that we have an idea of what it means to work with the explicit formula for arithmetic sequences, let's focus on the formula that we were given in general. A sub n is equal to the first term plus n minus 1 times d. If you need to pause the video to copy this down so it'll help you, that's fine. A sub n is equal to any term. A sub 1 is equal to the first term. N is how many terms we have in the sequence, and d is the common difference. So the practice that I've sent you, here's problem number 1. Let's take a look at it and how we would work it. The information is given to us as the first term is 7, the common difference is 8, the number of terms is 60, so therefore we want to find a sub n. So we're going to use the formula a sub n is equal to the first term plus n minus 1 times d. However, since we know that n is 60, we're actually looking for the 60th term's value. My first term is 7, the number of terms is 60, and my common difference is 8. Now you may need a calculator to do these calculations. 7 plus 59 times 8. When I add everything up, it's going to be 479. So the 60th term's value is 479. What's another way that this information can be given to us? Well, they can just write it out a little bit more formally. Find the 18th term of the sequence 8, 11, and 14. Once again, I'm going to use my explicit formula for arithmetic sequences, which will help me find any term that I'm looking for. In this particular problem, they didn't lay everything out for us perfectly like they did in problem number 1, but we can still figure out our answers by pulling out key pieces of information. For example, the 8. That's a sub 1, or the first term, so therefore a sub 1 equals 8. The common difference can be calculated by taking the 11 and subtracting it from 8. So 11 minus 8 is equal to 3. Now I ask myself, from 11 to 14, is it also increasing by 3? The answer is yes, so therefore my common difference is 3. I now need to see if I can figure out anything else in this formula, and I can figure out what n happens to work out to be because they asked for the 18th term. So 18 happens to be my n. Using my formula now, a sub n is equal to the first term plus n minus 1 times d, I can now figure out that 8 plus 18 minus 1 times 3 is going to give me 8 plus 17 times 3, which gives me an answer of 59. So again, once I know it's arithmetic, I can use my explicit formula to find any value that I'm looking for. What else can we do with this formula? Well, what if we're asked to find arithmetic means? Now, an arithmetic mean in this particular case means we want to solve or use our formula to find d, which is our common difference, because that's what's going to give us the next values. As you can see here, we have missing values. Our initial value is 3, so we now know that a sub 1 is 3. And we also know what our last value is, so we're going to call that a sub n in this case. The question is, do we know what n is? Well, if I count every single term, including the blanks, 1, 2, 3, 4, 5, 6, I now know that n equals 6. So what I'm looking for in this problem is d. I do not know what the common difference is, but I can still use my formula. A sub n is equal to the first term plus n minus 1 times d, where a sub n in this case is 33, or the sixth term's value is 33. My first term is 3. The number of terms is 6, but I don't know what my common difference is, so this just turns into a simple algebraic equation that I need to solve. 33 is equal to 3 plus 5 times d. Subtract 3 from both sides, I end up with 30 is equal to 5 times d. Divide by 5, and 6 is equal to d. Now that I know that my common difference is 6, I can go back up to my original problem and fill in the blanks. 3 plus 6 is 9. 9 plus 6 is 15. 15 plus 6 is 21. 21 plus 6 is 27. And I want to check this last one to make sure it works out, and it does. 27 plus 6 is 33. So I can use my explicit formula for arithmetic sequences to find the common difference, which is the arithmetic mean. What else can I do with this formula? I can also use my explicit formula to find the number of terms, which we call n. So let's say we were given the sequence 18, 24, 30, all the way out to 618. I don't know exactly how many terms I have. Now what's interesting is when you're solving for n, it should always be a positive integer as an answer. You can't end up with fractions, you can't end up with decimals, and you can't end up with negatives. So if your answers for n come out to be something other than a positive integer, you need to go back and check your math. You may have made a mistake. So let's see, once again, we're trying to fill in as much information as we can for the explicit formula for an arithmetic sequence. Again, how do we know this is arithmetic? Well, 24 minus 18 is 6, 30 minus 24 is 6, so this is an arithmetic sequence. Well, 618, well, that's my last value, or my last term. 18 is my first term, and I just found the common difference by observation to be 6. So I have everything I need except for n. I don't know what n will work out to be. Can I figure it out? Using my formula, I can now substitute in. A sub n, 618, is equal to the first term plus n minus 1 times d, which is 6. Now again, I got to distribute here. I end up with 618 equals 18 plus 6n minus 6. 18 minus 6 is 12, so I get 618 equals 6n plus 12, and now I finish the equation. Subtracting 12 from both sides, I end up with 606 equals 6n. Divide by 6, 101 equals n. So therefore, to summarize, the 101st term of my sequence has a value of 618. So the explicit formula for an arithmetic sequence, a sub n is equal to the first term plus n minus 1 times d, can be used to calculate any term in the sequence, which is what a sub n represents, the first term, if you wanted to find just the first term value, the number of terms, or the common difference.